Good evening everyone. Today we are gonna talk about activation records in function calls. So, in this PPT, we understand how programs manage function calls through activation records in Automata and compiler design. So, actually, what are activation records? An activation record, also known as a stack frame, is a data structure that stores information about the function call. When a function is invoked, the system creates a new activation record, which is easy to contain all necessary data to execute that function. And these records are organized on the call stack and creating in last in and first out LIFO manner structure that ensures proper function execution in return. So the structure of an activation record is in this manner: returns address, memory location to return to after function completion, and the parameters which are input values passed to the function, and local variables which are declared within the function scope. Static link reference to the including scope for nested functions, and dynamic link pointed to previous activation record on stack, and the return value which is the result of function computation. So the call stack in action actually happens like this: how function calls execute. Function call encountered in code. The function call will be encountered in the code, and the new activation record pushed onto the stack, and memory allocated for parameters and locals. Function execute with its context, real computed and stored record copied from stack on return. And when it comes to the visualizing the stack operations, first the push operation will perform when main calls function A activation record for function A is created and push it onto the stack. Stack pointer moves one point up. And then the nested call. When function A calls the function B, another activation record is pushed. Now the stack contains main function A and then function B. And pop operation. When function B returns its record is popped, stack pointer moves down, control returns to function A. And completion. Eventually, all the functions returns to the stack, returns to its position state with only the main function remaining. So the main role of this thing in the compiler design is lexical analysis. Compiler identifies the function calls in source code, and the syntax analysis also. Syntax analysis does the builds bash tree showing call structure, and the semantic analysis which verifies parameter types and scope rules. Code is generate and the main part code generation. It emits the instructions for activation record management, and at last the optimization. It may eliminate unnecessary stack operations and keep the only necessary operations. It can be implemented in different languages such as C++, Python, Java, JavaScript. In C++, manual stack management is possible, whereas in Python, dynamic stack management, and Java, automatic stack management, whereas in JavaScript, single-threaded loop, event loop. When it comes to C++, stack overflow can cause crashes. In the Python, recursion limit prevents overflow. Java stack overflow error exception is thrown. JavaScript call stack managed by the engine. So it can be implemented in different languages, and there are many advantages of using some languages, and there are many disadvantages of using some languages. Like in C++, pointer to stack memory are very risky. And Python uses heap extensively, and this is very beneficial. And in Java, objects are stored in a heap, and this is very good. Max call stack size varies by engine, which is very essential in JavaScript. So the common issues and challenges we face while doing this is first thing is a stack overflow. Too many nested function calls because we do many nested function calls, so that too many nested function calls exhaust available stack space. Common in infinite recursion results in program cache. So by doing the many nested functions, the program may result in a crash or an exception, which is not at all good. And the second issue is the memory leak. Activation records not properly deallocated can cause memory leaks. When the activation records are not properly allocated, they may cause memory leaks, which is very not good. The more common in languages with manual memory management. The third issue is the dangling pointers, references to local variables after the function returns. Actually, after the function returns to the references to the local variables, activation record is gone, but the pointer still exists, leading the undefined behavior. Performance overhead, and the final challenge issue faces the performance overhead. Creating and destroying activation records takes time. Excessive function calls can impact performance. Tail call optimization can help. So these are the common issues and challenges we face. So To overcome these common issues and challenges, we have some optimization techniques which are very helpful for us. Tail call optimization, when the function returns immediately after calling another. Reuse current activation record instead of creating a new one. When the function returns immediately after calling another, instead of creating a new one, we can reuse the current activation record, which eliminates the stack growth and which does not lead to the stack overflow. Function inlining. Compiler replaces function call with actual code body. Eliminates activation record certain entirely for small functions. Function inlining is very useful for the small function, whereas it eliminates the activation record. Stack caching. Keep recently used activation record data in CPU cache for faster access. This reduces the memory latency during the function execution, and this can be the memory essential. So when it comes to the key takeaways which we take from this PPT is foundation of the execution. Activation records are fundamental how programs manage function calls and maintain the execution context. And the second key takeaway is compiler responsibility. In this thing, the compilers must generate correct code to create, manage, and destroy activation records during compilation. Because if they do not give a correct code to manage, destroy activation records, then it may lead to some issues and challenges that we should face. And the memory management, which is very essential. Understanding activation records helps write efficient code and avoid common memory related bugs. So when you understand the activation records correctly, it helps us to write the efficient code, which helps us to does a good memory management. And at last, the debugging tool. Stack traces how show activation record chain, making them invaluable for debugging and understanding program flow. Mastering activation records is essential for understanding both automata theory and practical computer science. So in this PPT, we have the conclusion as mastering activation records is essential in understanding both automata and theory and practical computer in computer science. Thank you.